Welcome to N2 Electrical Trade Theory. This is chapter 4 on AC motors. The AC induction motor consists of two primary parts, the stationary part, which is known as the stator, and the rotating part, which is known as the rotor. The stator frame is the stationary part of the motor. The core consists of the primary windings, which is supported by the stator frame. It is the stationary part, which is made of cast iron or fabricated steel. The rotor is the rotating part of the motor, which contains the secondary windings. There are squirrel cage rotor made of rotor bars, usually aluminium, and they are short-circuited at the ends by means of end rings. The most common application for the squirrel cage rotor, it is used in AC induction motors. The advantages of a squirrel cage rotor: it has simple and robust construction, requires no maintenance, it has smooth and silent operation, and a long lifespan. The winder type rotor, also known as a slip ring motor, the main application for the winder type rotor is used in universal motors, such as portable hand drills. The slip rings on the end of the shaft are connected to external resistance, which allow for variable speed control. And these slip rings make contact with the external circuit to allow for current to flow. The advantages of a winder type rotor: it has high start torque. The high start currents can be limited using the external resistance, and speed can be controlled by varying the resistance in the external circuit. To produce a three-phase rotating magnetic field for three-phase motors, we take three coils, we place them 120 degrees apart, and the current through each coil is also 120 degrees out of phase with each other. The resultant rotating magnetic field is the combination of all three fields, which rotates around the motor in synchronous speed. Slip is the difference between synchronous speed and rotor speed. Now, if there is no difference between the rotor speed and synchronous speed, we'll find that no generated EMF will be produced. Therefore, there always needs to be slip in order for EMF to be induced. Here we have a star connection, the terminal box with 6 studs for a three-phase motor. We have 3 lives, red, yellow, and blue. And these studs have stator windings connected between them. We've got 3 coils, and they're labeled A1, A2, B1, B2, C1, and C2. Now, in order for this star connection to be bridged at the neutral point, we have to connect up A2 to B2 and C2 to B2. And by bridging those studs, we're able to connect this three-phase motor in star. The next type of three-phase motor that we get is a delta connected motor. Here we've got a terminal box with 6 studs, 3 lives, red, yellow, and blue. And we find that we still got our 3 stator coils between the studs, A1, A2, B1, B2, and C1, C2. Now, in order for this to be bridged as a delta connected motor, A2 and B1 must make contact, C1 and B2 must make contact, and C2 and A1 must make contact, and this would make it delta connected. This is just to illustrate to you what we mean by a three-phase motor. There are 3 sine waves, 120 degrees apart. Now, the big advantage of a three-phase motor is that it's self-starting because it has the difference in phases to allow it to start. If we look at this table below, we'll see and remind ourselves of the formulas required to do three-phase calculations. The symbol P represents true power. The symbol Q represents reactive power. The symbol S represents apparent power. The units for true power is kilowatts. The units for reactive power is kilovolts amps reactive. And the units for apparent power is kilovolts amps. Now, the most important thing to take note of in this three-phase table is that these formulas make use of square root 3, and we use line values. Here we have a capacitor start induction run AC motor. This is a single-phase motor, and therefore it only has one sine wave, which means there is no phase shift. So the big disadvantage of a single-phase motor is that it is not self-starting. So in order to start this AC induction motor, we take a starting capacitor, we connect it in series with a start winding. At the moment of start, the centrifugal switch will allow current to flow through the series start capacitor and start winding. The run winding and start winding are out of phase with each other by 90 degrees to try and create some sort of phase shift. Now, during the start cycle, as soon as the rotor reaches about 75% operational speed, the centrifugal switch will de-energize and cut out the start capacitor and start winding. The capacitor start capacitor run induction motor. In the capacitor start capacitor run motor, there are two capacitors. One is used during startup and the other is used as the motor runs at operating speed. The universal motor, also known as an AC series motor, there is an alternating field current through the field coils, and the universal motors are used as small hand tools or appliances such as vacuum cleaners or portable drills. Now, the universal motor is also known as the AC series motor, which means it has the same load characteristics as the DC series motor. So the universal motor can operate off both AC and DC. Here we have an illustration of a hand drill and the universal motor inside. In terms of overcurrent protection of motors, SANS 10142 stipulates two requirements. Overcurrent protection device shall stop the motor operating when single phasing occurs and must be manually restarted. So what do we mean by single phasing? A three-phase motor has three phases, red, yellow, and blue. The moment there is a fault current on one of those phases, single phasing occurs. Now, it's still possible for a motor to operate if there's a fault on one of the phases. Therefore, the moment single phasing occurs, your motor should automatically trip. Starting of induction motors. Starters are required for starting of large induction motors to reduce starting currents. Now, in terms of reducing voltage, there are two types of starters we can use. A star delta starter and an auto transformer starter are two methods of reduced voltage starting. How does a star delta starter work? When the motor is started, the stator is first connected in star while the rotor accelerates. When the speed of the motor settles down, the stator is switched to delta. Full voltage is then applied across the coils and the rotor accelerates further. What is the advantages of three-phase motors over single-phase motors? If we look at the illustrations, just to remind us of the difference between single-phase and three-phase. For single-phase, there's only one sound wave, and for three-phase, we have three sound waves, and those sound waves are 120 degrees apart. The big advantage of a three-phase motor is that it's self-starting. It has higher starting torque, it is more efficient, they are cheaper, and they are smaller in physical size.